So today we're going to look at Spearman's rank correlation coefficient, or normally just known as Spearman's rank. So we use why do we use Spearman's rank? We use Spearman's rank to look at correlation, so the relationship or connection between two things. Now, some things we know there's a connection with. For example, age and height of under 18-year-olds. We know that roughly speaking, as children get older, they get taller. So there would be a positive correlation with those. There are other things that as geographers we might suspect there's a correlation or relationship between. For example, number of tourists and width of footpath, or river speed and distance. But we may not be sure. So how can we look and see if there is a relationship? One thing we can do is we can produce a scatter graph. And you can see if we had a strong positive correlation or even a weak positive correlation, it would be quite easy to see through a scatter graph. And again, a strong negative correlation would be easy to see. But what becomes more difficult is if the correlation becomes weak, or even if there's no correlation, is there some kind of correlation but that's there by chance? So we can use a statistical test to say, yes, that relationship likely is there, or no, that relationship isn't there. And that's where Spearman's rank comes in. So when we're thinking about Spearman's rank, and any type of thinking about correlation, we need to think about the independent and dependent variable. The independent variable is the variable that we think is the one that is kind of separate, or the one that's in charge. And the dependent variable is the one that's impacted by that. So for example, in our previous example of children's age and height, age would be the X variable, height would be the Y variable. Now, in a minute, I'm going to demonstrate how to use Spearman's rank on a real example. But before we do, I think we need to think about, when do we use Spearman's rank? Now, this is important to think about now. It's also important to think about as you're designing your NEA, because it may be that you want to use statistical tests. You should do that because that helps you get the top marks. But you need to think about, what kind of data do I need to collect to be able to use a statistical test? So in the case of Spearman's rank, you need to have at least 8 pairs of variables, so pairs of data. So it tends to be things that happen where you've got 2 things recorded. So taking our age and height example, you've got that individual child and you're recording both their age and their height. They're a pair of data because they're linked on that child. It may be you're at a particular location, and that particular location you might be measuring the height of a building and the amount of litter. Those are paired because they're linked on the same data. So to use Spearman's rank, you need 8 pairs of data. So how does the test work? Well, the test works using that formula at the bottom, and you're going to end up with a Spearman's rank number of between -1 and +1. -1 being a perfect negative correlation, +1 being a perfect positive correlation. And I'm now going to show you through a demonstration video how to use Spearman's rank. Okay, so I'm going to talk about how to do Spearman's rank. So we've talked about it in theory. I'm now going to model how to do it in practice. So I've got a set of data here, and I've got my X variable and I've got my Y variable. Now my X variable is actually wind speed, and my Y variable is actually wave height. So what I want to see is there a correlation, is there a relationship between wind speed and wave height? So the first thing I need to do is think about my hypothesis. So my null hypothesis is there is no significant correlation between wind speed and wave height. Or my research hypothesis is in effect the opposite. There is a significant correlation between wind speed and wave height. So what I'm going to do is I'm going to use Spearman's rank test to work out to see if there is or is not a significant correlation. So I've got all my data in a table here. They're in matched pairs. So I have 10 point, when it was, wind speed was 10.3, the wave height was 3.2. Units don't matter, so I've taken out units. And what I'm going to do is I'm going to rank them now in order. So if I start off with ranking variable x, now I only rank variable x by itself, which is wind speed. So the first wind speed, the highest wind speed, I'm going to give a 1 to. And I'm going to work my way round. 16 gets a 2. And then looking for the next one, 13.4 is 3. 12.4 is 4. Now the next one I have a bit of a problem because the next one is 11.3 and there are 2 of them. So it wouldn't be fair for me to make 1, 5 and 1, 6 because they're the same. Equally, it wouldn't be fair for me to make them both 5 because then I'd skip a jump. So what I do is I give the value between them. So I make them both 5.5 and I continue working my way through the table, filling them out in rank order. Once I've done that for X, I will then do that for Y. Once you've worked out the rank of all of the X variables and then separately done rank Y, you then need to work out the difference between the X rank and the Y rank. So 7 take away 5 is 2. 4 take away 7 is minus 3. 4 take away 5.5 take away 4 is 1.5, and you work your way down the list doing that. Then to fill in the next column, I work out what d squared is. So 2 squared is 4. Minus 3 squared becomes 9. Now, for some of these, I may want to use a calculator. So 1.5 times 1.5 gives me 2.25. And you work your way down, getting all of the list done. So I'm going to do that now. So once I've worked out the difference between every rank, and I've then worked out d squared, I then need to work out the sum of d squared. So all I do is add them up. So 4 plus 9 plus 2.25 plus 42.25 and so on, all the way down, and add them up. And using my calculator, I get 176.25. So I add that here, 176.25. Now, I know that the larger this number, the bigger the difference is, the smaller the number, the less the difference is. But that doesn't actually tell me the Spearman's rank value. So I now need to plug the sum of d squared into my formula. So if I turn over to the other side of my sheet, or the second page, depending on how you got it, is I can plug in this bit here, the sum of d squared, we know is 176.25. We then multiply that by 6, and then we put that over n cubed minus n. Now n is the number of pairs of values. So how many data sets we have. For this example, it's 14. So n equals 14. So 14 cubed minus 14. So I now need to solve this. I'm going to use my calculator. So 14 times 14 times 14. So 14 cubed is 2744 minus 14. Then, so if I do the next level for that, it is 2730. And then here, 6 times 176.25 is 1057.5. I then also write that down here, 107.5. So sorry, 1057.5, and then I put that over 2730, and that gives me 0.387. So I'm going to take that 1 minus, and I'm just going to go to 3 decimal places, so 387, and then if I do 1 minus 0.387, I get 0.613. So that is my Spearman's rank value. However, that doesn't tell me very much. If I plot it on this number line, if it was minus, it would be a negative correlation. If it was +1, it would be a pure positive correlation. I'm about here. So that tells me there's a positive correlation between wind speed and wave height. So the bigger the wind speed, the higher the waves. But is it statistically significant? So to test significance, I look at my critical value table. To use my critical value table, I need to know my sample size. And in this case, my sample size was 14. In geography, we always work at the 95% significance value. So my significance value is 0.46. Because my Spearman's rank value is higher than 0.46, I can be 90% confident that there is a significant positive correlation between wind speed and wave height. So that is using Spearman's rank to check if there's a correlation between two sets of data. And in this case, there was a significant positive correlation between wind speed and wave height.